All right, so we're back and we are continuing to write recursive rules for sequences, but now we're going to kind of shift gears and go back to those non-arithmetic and geometric sequences. So you might want to write to yourself a note that these are non-arithmetic, non-geometric. So we're looking for the pattern, but it's not going to be as kind of like cut and dry as those formulas we had before. And by the way, you're not going to be given those formulas on your test. That's just something you're going to have to know. So if we look at this rule, 1, 2, 6, 24, 120, ... So we've got to find the pattern. Okay, so take a minute, pause the video, try to figure out what the pattern is. Don't just listen to me and let me tell you what it is. Okay, pause, go. All right, so now you've unpaused, you've figured out the pattern. Hopefully you've seen that we are multiplying by 1, then we're multiplying by 2, then we're multiplying by 3, then 4, then 5. Okay, so we have to kind of figure out how we can turn that into a recursive rule. Remember, a recursive rule, it relies on the previous term. You're going to take the previous term and you're going to multiply by what? Okay, so sometimes I think it helps if you start to arrange things. If we say that A1 is 1, we say that A2 is 1 times A1, right? That's what's happening. And A3, well, how do you get A3? So the third term is this guy right here. Well, you take the previous term and you multiply by 2. And A4, how do we get this 1, 2, 3, the fourth term right here? Well, we took the previous term and we multiplied by 3. Are you kind of seeing what's happening here? So then my next term, that fifth term, well, what happened? We took the previous term, which was the fourth term, and we multiplied by 4. So you've got to start to just come up, like you're seeing a pattern, hopefully, and it's like, well, how do I turn that pattern into math? How do I do that? So my first term is multiplied by 1. My second term is multiplied by 2. Do you see how these numbers are matching? Okay, so that's a pattern that we can kind of see and say, okay, well, we got a pattern there. Now compare them to the term number. So my second term, I'm multiplying by 1. My third term, I'm multiplying by 2. My fourth term, I'm multiplying by 3. So can you kind of see how we're always multiplying by 1 less? So our rule is going to be that we're starting A sub n. We're going to have to multiply by the previous term. So we're taking that A sub n minus 1, but then we're going to multiply by, here's my n. So if n is 2, I multiplied by 1. If n is 3, I multiplied by 2. So I multiplied by whatever n was minus 1. So my A sub n minus 1 times n minus 1. The previous term, that's what all of these are. Remember, a recursive rule is always going to need a previous term, and then times n minus 1. So that's this number here, and we compared it to that term number. Now remember, here's my rule. In order to write a recursive rule, you also need that starting term. So I'm also going to have to include that A sub 1 is 1. My first term is 1. Those are definitely a little bit trickier. Let's go ahead and try another one. So here's the pattern. Go ahead and look at it, pause the video, see if you can try to figure out the pattern, see if you can try to figure out the next term even. So you've unpaused the video now, you're super pro at this, you've seen what the pattern is, okay? Have you seen what the pattern is? You are adding the previous 2 terms. So I'm taking 1 plus 1 to give me 2, 1 plus 2 to give me 3, 2 plus 3 to give me 5, 3 plus 5 to give me 8, 5 plus 8 to give me the next term, which should be 13. So if you can sometimes figure out just what the next term is, then you can feel confident in your pattern. So that 13 is that next term. Now what we're doing here, kind of think about this. I can't really start my pattern until that third term. My third term comes from taking the second term plus the first term, these two here. That's how I got my third term. My fourth term, this right here, I got from adding the previous term, the third one, and the second previous term, the second term, so A3 plus A2. So then my fifth term, right here, I'm getting from the previous two terms, so A4 plus A3. So you can kind of see the pattern. Here we're adding the previous two terms. So my rule is going to be A sub n equals A sub n minus 1. So that's the previous term, plus, how do you think we're going to get the previous term? Well, look at my n. So n minus 1 gives me 2. 4, n minus 1 gives me 3. 5, n minus 1 gives me 4. How am I going to get these numbers? Woo. See how we're going to be subtracting 2? So that's A sub n minus 2. So because this rule needs us to have two previous terms, remember at the beginning when I said, hey, let's write this down. And sometimes you need that S in parentheses. Well, now is that time. So we actually have to include that first term, which is 1, and we have to include the second term, which is also 1. The reason being is that our rule depends on two previous terms. There's a special name for this sequence. It's called the Fibonacci sequence, if you've never heard of it. All right, so the very last part of this is just talking about an iteration. An iteration is very similar to that of a recursive sequence. It's just that it's the repeated composition of a function within itself. Okay, so it's because we're dealing with functions now instead of sequences. That's really all it is. So if I ask you to find the first three iterates of a function given the initial value, now we have that x sub 0, or whatever the starting value is that they want us to start with. So if x sub 0 equals 2, that just means that I'm going to find x sub 1 by doing f of x sub 0. So all that means is that I'm taking x sub 0 and I'm plugging it into the function, right? If this was f of 3, you would plug in 3. So I'm plugging in f of x sub 0. And well, x sub 0 is 2. So we are going to take f of 2, which is going to be negative 3 times 2 plus 1, which is negative 5. So the first iteration here is negative 5. If I wanted to get x of 2, well, all I would do is I would take f of x sub 1. So now I'm going to take x sub 1, which you can see is negative 5, and we're going to plug that into the f function. So we're doing f of negative 5 now. So negative 3 times negative 5 plus 1 is 16. And then you do the same thing for the third one. Well, now I'm plugging in x2. So we're just taking this and we're doing compositions within itself. Composition, you remember when we plugged one function into another? Well, it's not a function, you're just plugging in this iterate. So this means I want f of positive 16. Sorry. So negative 3 times 16 plus 1 is going to be negative 47. So there's the first three iterates of that function. So we could do that one more time if you would like, and then we'll just call it wraps here. So we can do it a little bit quicker here. If I want x1, all I'm going to do is I'm going to plug this into f of x. Whoa, come back to me now. Okay, you're probably getting dizzy right now. All right, let's hope that stays. So now I'm going to take negative 1 squared minus 5. So that's negative 4. Then to get x2, now we're taking that negative 4 and plugging it in. So do you see how all we're doing here is recursive function? Okay, but now that we have a function, we're calling it an iteration. That's really all it is. And then x3 is 11 squared minus 5. Now, I will say that when you're dealing with iterates, you're usually starting with x sub 0 as opposed to recursive functions, you're starting at a sub 1. So you just want to be a little bit careful when you're working with that. All right, guys, good luck on your homework.